In the previous lesson, we were studying how to graph quadratic functions. Our focus, for the most part, was finding the vertex. There was two different ways to find the vertex. Remember the vertex formula or completing the square in x. Our focus was on finding the vertex, and all other points were kind of secondary. The vertex was like the most important point on the parabola. Here in this section, you're going to see that that is not as important anymore, the vertex. In order to solve a quadratic inequality, you're going to see, hopefully, that the x-intercepts are the points that you and I are most interested in finding in order to solve a quadratic inequality. So here's our strategy. To solve a quadratic inequality, we'll need two things. The direction of the parabola, meaning is it opening up or down, and the x-intercepts. Now, notice how I wrote it on the screen. I put the x-intercept or the x-intercepts, if any. I want to remind us that a parabola, the graph of a parabola, does not have to touch the x-axis at all. If a parabola does not touch the x-axis at all, you don't have any x-intercepts. And then it's also possible for the parabola to touch the x-axis only once. In that case, you only have one x-intercept. And then there's the third case where a parabola can touch the x-axis two times. In that case, you have two x-intercepts. We'll go through these together in the next following examples. All right, everybody, let's practice finding the x-intercepts for this function. F of x is equal to x squared plus 2x minus 3. Now, recall that x-intercepts are found by plugging 0 in for y, or f of x. Remember, f of x just represents y. So what I'm going to do is I'm going to let f of x, all of this notation on the left-hand side, all of it, be 0. So that would give me 0 is equal to x squared plus 2x minus 3. Now, I'm going to rewrite this so that it's set equal to 0, but on the right side instead. I just prefer to see my equation set equal to 0 on the right. Now, how you solve this, you have a few options. Whenever this is called a quadratic trinomial, because it's three terms. Tri meaning three. 1, 2, 3. Whenever trinomial factors, I prefer to use factoring to solve. So let me illustrate that now. To factor means to rewrite the sum of these three terms here as a product of factors. So if it factors, then it's going to have to factor like this, okay, as a product of two binomial factors, as a product of two terms, as a product of two term polynomials, all right? Now, we know that whatever you write here and here must multiply, right? When you distribute, this must multiply to that term to give you your leading term, x squared. So the question is, what times what gives me x squared? You should be thinking, well, x times x gives me x squared. So that's exactly how this factorization begins. The next thing I want you to consider is whatever you write here and whatever you write right here must multiply to give you negative 3. Wait a minute. The only way a product like this will give you a negative output is if the signs are different. So just by looking at this sign right here, because it's negative, that tells me that these two terms right here must have different signs so that when I multiply them, I get a negative product. If the signs were different, if the signs were the same, I would get a positive product, and that's not what I have here for the last term. So I know that one of them will be a plus sign and the other one will be a minus. So that a positive number times a negative number gives me a negative product. Now, as far as what numbers I put here and here, I can only use factors of this last term. In this particular example, factors of 3 are just 1 and 3. 3 is prime after all. So I have to figure out where do I put the 1 and where do I put the 3? Well, if I put the 1 here and the 3 here, now I think we all can see that 1 times negative 3 is indeed negative 3. Bingo, right? But the problem is you're not going to get positive 2x. And let me illustrate that now. Check this out. So we already confirmed that x times x is x squared. That's good. And we confirmed that 1 times negative 3 is negative 3. So we got this term and we got this term. So we're good. But I'm going to show you right now that when I finish distributing, I'm not getting positive 2x. So I have to also consider this product, x times negative 3, and this product, 1 times x. What would that give you? X times negative 3 is negative 3x, and 1 times x is positive x. And when you combine these two terms, you get negative 2x. The problem with that is your middle term is not negative 2x. It's positive 2x. So then this must be the wrong factorization. What was wrong about it? Well, I got 2x all right, but the sign was off. That must tell me that this must be negative and this must be positive. Switch the signs and it'll work. So try this. And I suggest you check your factorization as you go. And I'm not checking for x squared. I already know that I got that. I'm not checking for negative 3. I already know that it works. The question is x times 3 plus negative 1 times x, does that give me positive 2x? So that's really what I'm focused on checking right now. X times 3 is 3x, and negative 1 times x is negative 1x. And this gives me positive 2x, and that's exactly what I was looking at finding here. So it works. So factoring is one way to solve a quadratic equation, but when you're factoring, you may want to consider checking your distribution to make sure that this factorization indeed is equivalent to your trinomial, okay? Now we're going to use something called the zero factor property that says that if this factor, it's a binomial factor because there's two terms, if this factor times this factor is equal to 0, if the product of these two factors is 0, one of the factors must be equal to 0. Let me say it like this. If this times this equals 0, then one of these factors must be 0. So what we do is we take each of these factors and we set each of them equal to 0 and solve. So you can see that if in this one we're going to add 1 to both sides, here we're going to subtract 3 from both sides, and you're going to get x is either 1 or x is negative 3. What you just found right now are the x-intercepts of the graph of this quadratic. Allow me to please write them in ordered pair form. 1, 0, remember we plug 0 in for y, and negative 3, 0. All right, so those are the x-intercepts. All right, now that we've found the x-intercepts for this quadratic function, we can now solve a number of quadratic inequalities for this function. Let's look at this one, which says x squared plus 2x minus 3 is strictly greater than 0. And then once we walk through this one, we'll consider the other three, okay? The first thing I would love for you to consider is what this symbol means. Strictly greater than 0 means that you're positive. If you're something that's greater than 0, then that means you're positive. And in the x and y coordinate plane, in order to be positive, you must be above the x-axis. So this is really asking you, graphically speaking, when is this parabola above the x-axis? Okay, so keep that in mind when we sketch a rough picture of what's going on. All right, the next thing I would like for you to consider is, what is the direction of this parabola? Does it open upward or downward? Well, hopefully you'll remember from the previous lesson, when the leading coefficient, which in this case is positive 1, is positive, then that means your parabola opens upward. All right, in addition to opening upward, we found this information a few minutes ago. With this information, just these two pieces of information, I can sketch a picture of my parabola. Now, I'm not going to get fancy here, and I'm also not interested in finding the vertex. I don't really care, okay? So here is what we have, something like this, okay? This should do it. Okay, now keep in mind, I'm only really interested in the x-intercepts and the orientation or the direction of my parabola. All right, the parabola goes through -3 and it goes through 1 and it opens upward. So it does something like this, everybody. That's all I need to know. All right, now remember, so I'm ready to answer the question. I'm ready to answer the question. The question being is, when is the parabola above the x-axis? Well, look at your picture. The parabola is above the x-axis in that piece and in that piece. So basically, you would say the parabola, remember that this branch is going forever to the left, okay? Forever to the left. Remember, you're solving for x, everybody, right? When you're solving a quadratic inequality, you're solving for x. Because you're solving for x, you want to focus on the x-axis. And this branch is going forever to the left on the x-axis. This branch is going forever to the right on the x-axis. So then your solution set is from -infinity, because it goes forever to the left, to -3, union from 1 to positive infinity. You would skip this piece of the parabola because this piece is not above the x-axis. It is beneath or below the x-axis. So in interval notation, your solution is from -infinity to -3, a parenthesis. The reason why there's a parenthesis on this -3 is because -3 is not included in the solution set. How do I know it's not included? It all goes back to what kind of inequality symbol this is. This is a strict inequality. That's what made me put a parenthesis at -3. It is not included. Some of you learned that when you have a strict inequality, then that means your x-intercepts here would have an open circle, like that. Okay, so some of you learned that way. All right, so that's the equivalent of the parenthesis. All right, so I got this piece here, everybody. So now union, the next piece is parenthesis at 1, positive infinity. This is the solution set. That is to say, the parabola will be above the x-axis to the left of -3. It'll also be above the x-axis to the right of 1. All right, now we considered this inequality. Now let's consider solving this inequality. Now guys, this inequality is exactly the same as this one. The only thing that's different is the symbol. Instead of strictly greater than, it is greater than or equal to. The only difference between the solution sets of these inequalities is I will have a bracket at -3 and +1. That is to say, I will include -3 and 1 because this is non-strict. So looking at the next inequality, it still means above the x-axis, okay? It's still opening upward. The x-intercepts are still the same, but this time, notice I closed in the circles. This time I should be including my endpoints, my x-intercepts. So the solution set is almost identical. Negative infinity to -3, but a bracket at -3 to include it. Union, a bracket at 1, and then to positive infinity. All right, now let's look at the next one. This quadratic inequality still says that the parabola opens upward, all right? The x-intercepts are the same. The only thing that's different here is this inequality is strictly less than. Let's look at that now. All right, I wrote it for us. X squared plus 2x minus 3 is strictly less than 0. Now, think about it. When something is less than 0, that means you're negative. And in the x and y coordinate plane, if you're negative, that means you're below the x-axis. So this symbol means below the x-axis. Now, I want you to keep in mind the parabola still opens upward. You know, this quadratic expression hasn't changed. It doesn't change for any of these, right? The left-hand side of the inequality is still exactly the same. The parabola still opens upward. The x-intercepts are still 1, 0, and -3, 0. Nothing's changing with the graph. But what we focus on is changing. Now we're focusing on when is the parabola beneath or below the x-axis. What's below the x-axis between -3 and 1, or from -3 to 1. I'll highlight it for you. It's below the x-axis from -3 to 1. Now, these are open circles here because this is a strict inequality. That means I will not be including the endpoints -3 and 1. I will not include the x-intercepts. So I'll be using parentheses when I write down my endpoints. So here's the final solution set. The quadratic inequality is strictly less than 0. That is to say, the parabola is below the x-axis from -3 to 1. Done. There's only one interval. There's only one piece for which it is below the x-axis. That's it. Now, let's look at the last one. This is identical to what we just did right now. The only difference is now the inequality is non-strict. And by now you probably have an idea of what this means. Non-strict just means we can now include the endpoints. We can put brackets at -3 and 1. Let me show that. All right, I swapped out the inequality symbol. Now it's non-strict, less than or equal to 0. It still means when does a parabola go below the x-axis? The parabola still opens upward. The x-intercepts are the same. Now I closed in these x-intercepts. For some of you, that might make a lot of sense because that's how you learned. So it's below the x-axis from -3 to 1. And now in my interval notation, I'm actually putting brackets at those endpoints to denote that we are including those values for x in the solution set. All right, everybody? So that's our first quadratic inequality. Allow me to summarize. In order to solve a quadratic inequality, you need two things. You need to figure out or determine the direction of the parabola, and you need to determine the x-intercepts, if there are any. And with those two pieces of information, you can answer the question. What do you mean the question, Professor? The inequality symbol is telling you what the question is. This says, when is it above the x-axis? When is it above the x-axis? When is it below the x-axis? When is it below the x-axis? Remember that this inequality and this inequality are non-strict, which means you should include the x-intercepts. That means you should be putting brackets on the endpoints, on the x-intercepts. This inequality symbol and this inequality symbol are strict inequality. So you should be putting parentheses, meaning exclude the x-intercepts in your final solution set. All right, let's practice some more. Let's look at another quadratic inequality. All right, check this out, everybody. Find the x-intercepts for this quadratic function. All right, let's go for it. So I have negative x plus 1 quantity squared set equal to 0. I'll take this time to remind you why I set it equal to 0. In order to find the x-intercepts, this is what we wrote down a little while ago. We plug 0 in for y. Now y is exactly what g of x represents. So I'm letting this left-hand side, this entire notation right here, function notation, be 0, okay? And then instead of saying 0 is equal to this expression, I'm saying this expression is equal to 0. In other words, I'm just putting the equal to 0 part on the right-hand side. Okay, so watch how I solve this. Now keep in mind there's many different ways to solve this quadratic equation set equal to 0. This here is a -1. I know you don't see the 1, but this is really like a -1 as a coefficient. So what I'm going to do is I'm going to divide both sides by -1. What is incorrect is to distribute this negative inside of this squared expression. That you cannot do. All right, so here I go. I am going to divide both sides by -1. All right, what that does for me is this negative and that negative cancel out, and I'm left with just x plus 1 quantity squared is equal to 0, because 0 divided by -1. 0 divided by any non-zero number is just 0. Now, what I would like for you to do is to undo or get rid of, eliminate this squared expression, or this exponent of 2. What will do that for you is by taking the square root of both sides. So I'm going to show that now. So I'm going to take the square root of the left-hand side and the square root of the right-hand side. This is called the square root property. The square root action cancels out the squaring action because they are inverse operations. So I'm just going to kind of like put a slash through that and a slash through that, so that you just have x plus 1 by itself is equal to, now remember that this notation, square root of 0, is asking you for the real number whose square is 0. Said another way, it's asking you for the number such that when you square it, you get 0. Well, that just means it's 0, because 0 is the number such that when you square it, you get 0, right? 0 squared is 0. Now, once I subtract 1 from both sides, I get x is equal to -1. Notice you only have one solution for x. What does that mean as far as x-intercepts are concerned? It means you only have one x-intercept, only one. The x-intercept is -1, comma 0. Don't forget that you let y, or your function value, g of x, be 0 in the beginning. So that's that 0 there. All right, cool. Now that we have the x-intercept, singular, right? The x-intercept for this quadratic function, we are now able to solve some quadratic inequalities for this function. All right, check out these inequalities. Now keep in mind the quadratic expression is exactly the same, okay, everybody? But now it's not set equal to 0 or anything like that. It's greater than 0, greater than or equal to 0, strictly less than 0, less than or equal to 0. All right, let's go one by one here. All right, so we know from the previous example already that greater than 0 means above the x-axis. All right, now let's keep a few things in mind. Is this parabola opening upward or is it opening downward? Well, because the leading coefficient is negative, we know that this parabola is opening downward. Instead of writing that out in words, I'm just going to draw a little diagram for myself. I have a parabola opening downward because the leading coefficient is negative. And then in addition to that, I know that the x-intercept is -1, comma 0. With these two pieces of information right here, I am going to draw my graph, okay? And it's just going to be a quick sketch, all right, everybody? A quick sketch. So here's -1 on the x-axis, and my parabola is doing this. There's my parabola. this is the parabola for all of these, right? Because all of these squared expressions are exactly the same on the left-hand side. So this is the picture for whatever inequality you want to consider solving. This is the picture you're looking at. So again, all we really cared about was the x-intercept and the direction. Hey, just for this example, notice that the x-intercept happens to be right on the x-axis. And notice that whenever the x-intercept happens to be right on the x-axis, that is also the vertex. It's kind of cool. All right, so let's think about it. When is this parabola above the x-axis? Wait a minute. This parabola is never above the x-axis. It's always below, actually. It's never up here. So I'm going to say no solution. There is no solution. And by the way, I am not allowed to include -1. This x-intercept, you cannot include it because this inequality is strict. What some of you probably want to do is make that point that you don't have to, but make that x-intercept an open circle. If that's how you learned with open circles and closed circles, then that's probably what you want to do. Because this is a strict inequality, you're not allowed to include this point. So going back to the final answer, when is it above the x-axis? It's never above the x-axis. You can see that in the picture. So your final answer is just no solution. No solution. Of course, you don't have to write that answer out in words. In interval notation, it's just like that. Okay? All right, now let's shift our attention to this inequality, greater than or equal to 0. Now keep this in mind. This question here is exactly this question that we just considered, with the exception of we are now allowed, and not just allowed, we should be including the x-intercept. All right, so I switched out the inequality. I'm focusing on this one now. The graph is still the same. The x-intercept is still the same. This is still asking you when is it above the x-axis, but really it's asking you when is it either above the x-axis or actually equal to 0. In other words, this is asking you when is it above the x-axis or right on the x-axis. So we already determined that it's never above the x-axis, but it actually is right on the x-axis right here. It's actually equal to 0 right here. Remember the ordered pair, everybody, here? Here, I'm going to remind us. The ordered pair here is -1, 0. So this inequality is saying, when is it greater than 0 or equal to 0? Well, it's never greater than 0, but it is equal to 0 right here, right? It's equal to 0 at that point. So then this inequality only has one answer, and that is it's equal to 0 at -1. Notice I'm using braces and it's not interval notation because there's only one value of x for which this inequality is equal to 0, and that's -1. All right, everybody, I'm now ready to shift my attention to this one here. All right, everybody, strictly less than 0 means below the x-axis, below the x-axis. All right, I also made this an open circle for some of you, or if that makes sense for you, that's fine. So when is it below the x-axis? Well, you might be thinking, well, it's always below the x-axis. The whole parabola is below the x-axis. You'd be right, except you're not allowed to include this point. You have to skip over this point because this inequality is strict. So basically, if you'll allow me to highlight, the answer is from -infinity union to -1, excuse me, from -infinity to -1 union from -1 to positive infinity. So the final answer would be -infinity, -1, parenthesis, because of the strict inequality, union from -1 to positive infinity. So that's basically saying, in words, the entire parabola is below the x-axis except for at -1. Now, last one, less than or equal to 0. Everything is exactly the same as what we just finished saying, except now we can actually include this point. Wait a minute, if you include this point, That means you're including every point that's on this parabolic curve. Where this curve goes infinitely to the left and infinitely to the right, correct? So then if you are now less than or equal to 0, then your answer should be all real numbers. All right, so what I did was I changed the inequality to less than or equal to 0. It still means below the x-axis, and I closed in the circle. So when is this parabola, when is it below the x-axis or actually equal to 0, meaning right on the x-axis, right? So it is always, as what we just described, it is always either below the x-axis or right on the x-axis. So we're going to say all real numbers. All right, very good, everybody. Let's look at another quadratic. All right, find the x-intercepts for this quadratic function. Now again, don't forget to find the x-intercepts mean that you plug 0 in for y. The notation h of x represents y. All right, so here we go. I am going to take my function and set it equal to 0. Now, the very first example, example number 1, I showed you how you can factor. If you try to factor this, it will not factor, no matter what you try, okay? So I need another method. There is something called the quadratic formula that will allow me to solve any quadratic equation. I'll say that again. The quadratic formula always works for solving a quadratic equation. Factoring does not always work, but the quadratic formula always does. Please allow me to remind you what the quadratic formula says. It says that when you are solving a quadratic equation for x, x will be equal to negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Now, let's remember that when we're talking about a is your leading coefficient, which in this case is 1. B is the coefficient of your first degree term, which in this case is negative 2. And then C is positive 5. Be careful here. B is negative 2. B is not 2. B is negative 2. So then when I use this quadratic formula for this equation, I get negative 2. Did you catch that there? This negative in the formula comes with the formula. And then when you plug in B, you're plugging in negative 2. So it's negative 2. So be careful with your signs there. Plus or minus the square root of b squared minus 4 times a times c all over 2 times a. When you simplify this expression, it'll give you your x-intercepts, if you have any. All right, so let's try to simplify this expression. All right, so we're getting positive 2 out front, plus or minus square root of 4 minus 20 all over 2. Allow me to scoot up here. Okay, about right there. Then x is equal to 2 plus or minus the square root of negative 16 all over 2. This gives you x is equal to 2 plus or minus. Now, watch this. What number squared gives you negative 16? You should be thinking right now, Professor, there is no real number such that when you square it, you get negative 16. Because whenever you square a real number, whether it's negative or positive, you always get a positive result. So this is impossible in the real numbers, and you'd be exactly right. What this really means is for I. The negative underneath the square root is how we defined the imaginary unit I. I is defined to be the square root of negative 1. I'll write that down on the side. I is equal to the square root of negative 1. So this negative underneath the square root is what is generating I. If you ignore that for a second, let me cover it up with this arrow, this cursor. The square root of 16 is 4. That's why I wrote down the 4. The negative underneath the square root is what's giving me I. The point though here is, and let me scoot up here, the point is, what are your x-intercepts? That's what I was trying to find. What are the x-intercepts? Well, your x-intercepts in the Cartesian plane, the x and y coordinate plane, are real numbers. However, the solutions for this quadratic equation are not real. These are not real solutions. These are imaginary solutions. So, because your solutions are not real, it means you do not have any x-intercepts. All right, everybody, so there are no x-intercepts at all. So this parabola never touches the x-axis. Now we're ready to solve some quadratic inequalities for this function. All right, everybody, just like before, we're going to now look at some inequalities. This means above the x-axis. This means above the x-axis. This means below the x-axis. This means below the x-axis. Let's go. Now, the two things we know for sure right now is that this parabola opens upward. Instead of writing out the word upward, I'm just going to draw a parabola going upward. We know that because the leading coefficient is positive 1. It's positive. The other thing we also know is that there are no x-intercepts. That is to say, this parabola never touches the x-axis. So, with those two pieces of information, we must understand that if this is the x-axis, okay, everybody, this is the x-axis, we must understand that the parabola that we're considering looks something like this. It's going upward, and it's never, ever, ever, ever touching the x-axis. I know I didn't draw the y-axis, didn't I? Or did I? I don't care about the y-axis, to be honest. It's not going to change my answer. So I'm really just focusing on this parabola and how it behaves with respect to the x-axis. All right. Okay, looking at the first inequality, when is the parabola above the x-axis? You should say the entire thing is above the x-axis. So my final answer here for this inequality will be all real numbers. What that means is no matter what x value you plug in here, you will always end up with something that is greater than 0. That's what that means. No matter what real number you plug in, you will always end up above the x-axis. Let's go for the next one. Greater than or equal to 0. Now, this one is non-strict, so that means it's greater than, above the x-axis, or even if it hits the x-axis, that's okay. This parabola never hits the x-axis, but it does satisfy the first part of that symbol, which means it's above the x-axis. Let me break that down again. Greater than or equal to 0 means find out when this parabola is either above the x-axis or right on the x-axis. Well, it's never right on the x-axis, but it is always above the x-axis. So your solution here, again, is all real numbers. Meaning, no matter what x value you plug in here, you will always be either greater than 0 or equal to 0. Okay, let's go to this one, less than 0. Now, this is asking you when is it below the x-axis, and you should say it's never below the x-axis, so that should be a clear no solution for you. It's never below the x-axis. Okay, next one. This one is non-strict. It's asking you when is it either below the x-axis or right on the x-axis. Neither of those two things happen. It's neither below the x-axis nor right on the x-axis. It's neither less than 0 or equal to 0. So again, no solution. All right, cool, you guys. Let's continue. Okay, folks, this will be the last example we look at for this lesson. This one says, let's get right to it. Solve 3x squared minus x is less than or equal to 4. All right, so let me walk you through this problem. First of all, we know that we can subtract 4 from both sides, and so that this inequality can be rewritten like this. Okay, what does this mean now? Well, because this is quadratic, it's asking you when is this parabola either below the x-axis or right on the x-axis. When is this parabola less than 0 or equal to 0? All right, so there's two things we need, right? We need the direction of the parabola, which you can already see since the leading coefficient is positive, it's going upward. The second thing we need are the x-intercepts, if it has any, all right? So let's go through it. This parabola is going upward because the leading coefficient is positive, so that's helpful. The next thing I need are the x-intercepts. Do you remember how to find the x-intercepts? Set this equal to 0 and then solve. That's what we've done to find the x-intercepts for each of the problems. Now, how do you want to solve for x? You can use the quadratic formula. You can try to factor if it factors. Let me check to see if this factors. Now, if it factors, it's going to factor like this. You and I know that whatever I put here and here must multiply to give me 3x squared. Well, that leads me to believe that one of them has to be 3x and the other one has to be 1x, because 3x times 1x gives me 3x squared. All right, that's good. The next part is whatever you put right here and here must multiply to give you -4. That tells me that the signs are going to have to be opposite. One of them is going to have to be plus and the other one's going to have to be minus, but I don't know which one is which yet. I'm going to have to play around with it. As far as the numbers that I can consider, I want to consider factors of -4. Now you have some options. Here are your options. You could either do 4 times -1, which is -4, or +1 times -4, that's -4, or 2 times -2. All right, so you have to play around with these, and you know, the question is not, are you going to get -4? No, you are, because all of these products are -4. The question now under consideration is, which one of these pairs gives you a middle term of -1x? Let's see. Let me play around with 2 and -2. All right, so if I put 2 in one, -2 in the other, does that work? When I say that does that work, I'm not talking about 3x squared. We already know we got that. We already know we're going to get -4 because 2 times -2 is -4. The question, one more time, is are we getting a -1x? You can check by distribution. What's 3x times -2 plus 2 times x? Does that give you -1x? Well, 3x times -2 is -6x, and 2 times x is +2x, and this gives you -4x, which is not, hold on just a second, which is not what you wanted. You didn't want -4x, you wanted -1x. Now, even if you change the signs on these, let me say, well, maybe we need to switch the signs. Maybe this needs to be minus and this one needs to be plus. Okay, let's try that out. What would your product be? Well, you can see, hopefully, that you're getting 3x times +2, which is +6x, and -2 times x is -2x. This just changed the sign on that product, and now it's +4x. I didn't want +4x. So what I just figured out here, just after a minute or so, is that this pair of factors is not working. So I'm going to have to try one of these, all right? Okay, so let's try 4, +4, and -1. Let's see if that gives me that middle term of -1x. All right, so we're checking the distribution, right? What would that give us, everybody? 3x times -1 is -3x, and 4 times x is +4x. This gives me +1x. You know, that was really close, right? I want -1x. 1x. Wait, if I just want negative 1x and I just finished getting positive 1x, all I have to do is, you got it, switch the signs, right? So let's make this one negative and this one positive. Let's check that. All right, check that distribution. Now you're getting positive 3x and a negative 4x, which indeed gives you negative 1x. Bingo, that's the middle term that I wanted. So we have the factorization. Now I want to reiterate what I said earlier. Now I encourage you to practice your factoring. I know a lot of us need that extra practice. And at the same time, remember that the quadratic formula always works for any quadratic, okay? All right, here we go. What we're going to do now is set each of these factors equal to 0 and solve. Here, when you subtract 1 from both sides, you get x is equal to negative 1. That's an x-intercept. Over here, you're going to have to add 4 to both sides, which gives you 3x is equal to positive 4. And then you'll have to divide both sides by 3, which would give you, let me move up here, there, which is going to give you x is equal to 4/3. This is the other x-intercept. All right, let's not forget what we're solving. We are solving this question, which is asking, when is this parabola below the x-axis? We know the parabola is opening upward, and now we know the x-intercepts. Let's sketch a quick little picture. All right, everybody, here's a rough sketch of our parabola, all right? Negative 1 was one of our x-intercepts, and 4/3, which is a little bit greater than 1. All right, what is this asking? When is it below the x-axis? When is it less than 0 or equal to 0? Well, I can highlight that for us. It is equal to 0 right here. It's less than 0 here. It's equal to 0 here. So then our final answer is going to be from negative 1 to 4/3. You know why there's brackets on the endpoints? Because that is non-strict.